What we are going to do today is finish chapter 15, and then hopefully by noon we'll finish chapter 15. And then you have a quiz on Wednesday. I have a sheet that's going to help you with that quiz. So I'm going to hand that out, a practice worksheet. You can take it and do what you want, but I'll show you how to use it, and it'll really narrow down the scope of reactions there's probably 8 or 10 of them, but the scope of reactions that you can anticipate on Wednesday's quiz. What we need to cover in chapter 15 is reactions of amines and the amides, and how to name amides, and a little bit about amides. And then there's a whole bunch of slides at the end that are just kind of examples of biologically important amines and amides, and from a point of view of naturally occurring, like dopamine, to synthetic. So we're going to look at a whole bunch of molecules that have medical, biological significance. All right, first thing, we haven't really gotten to the amides yet, but just to mention here that under how would you make an amine, you can make an amine from an amide. So this is an amide, and if you were to react an amide with a hydrogen, with a reducing agent of some sort, this is reduction. And so what you're actually doing, you're adding hydrogen to that oxygen, and I think it strips it off as water, and you see you end up, you put a hydrogen in here, you put a hydrogen here, and you end up with an amine. So this is an amide, and it's an amide with a methyl group on the nitrogen. You end up with a secondary amine. So that's one way to prepare amines. And another way, same sort of thing, reduction of a nitro compound. Like nitrobenzene can be reduced to form aniline. I'm going to just mention these. These probably won't be reactions that I say you need to be able to complete. But just know that's how you could prepare an amine, from the reduction of an amide or a nitro functional organic compound. This is a simple but important little reaction. Oh, let me just introduce this by saying that what you need to understand is that amines are weak bases. So I'll pull that slide down in just a second. But again, review from 1305. If you bubble ammonia into water and make a solution of ammonia in water, remember there's an NH3, there's a bunch of hydrogens there, but that's not acidic. That thing does not actually lose hydrogens. The ammonia actually attracts a hydrogen off of the water. All right, so you got H2O over here, and the ammonia is a proton acceptor. It's accepted that hydrogen off of the water. So what's left? OH. And what's its charge? Negative. This is a hydroxide ion. This is a base. So we say ammonia is a weak, it's a base. Ammonia is a base, and it is a weak base because it doesn't do this 100%. If you bubble the ammonia into water, you don't just end up with ammonium hydroxide. You end up with ammonium hydroxide, ammonia, and water all mixed together. And actually greater than 90% of it is over here, and less than 10% of it, actually probably less than 3% of it, is actually ammonium hydroxide. So it is a weak base. So if you bubble this into water, you'd get something a pH of approximately, I'd say about 9.5. Remember, what's the highest pH you can get? 14. Can't get any higher than 14. You put sodium hydroxide in water and you get up a pH of about 12 to 13. Very high pH, very basic, strong base. Ammonia is a weak base. Okay, now, we're not talking about ammonia, we're talking about amines, right? So let's take a simple amine. And I always kind of like to show it attached to the nitrogen. Let's bubble it into water. And let's figure out, all right, now here is your amine. This is going to behave like the ammonia. Just happens to have a methyl group over here. So you're not going to get NH4 plus. You're going to get NH. If this gains one hydrogen, what are you getting up with over here? NH3. NH3 plus and hydroxide ion. So ammonia is a weak base. Amines are weak bases. So I don't have a slide for it, but you should be able to complete this kind of reaction or expression here to show what would happen when amines are dissolved in water or bubbled into water. They're going to raise the pH. So a multiple choice question might be, amines are neutral salts, weak acids, weak bases, none of the above, whatever, okay? You should know fundamentally that amines are weak bases. They're bases. Just happen to be weak bases, but they will make water solutions basic. All right, now that is appropriate as starting material for this right here. What we got right here, so that's a propyl. What we've got then, this is propylamine, so what we have here is a base plus an acid. And you know that general reaction, a base plus an acid forms a salt and water. That's a neutralization reaction. And why does this happen? Well, because amines are bases. And it will react with an acid. And this isn't water over here, this is HCl, but the H is going to go on here, NH2 or NH3 plus, and the chloride. So you're getting that and that. And I was just explaining up here a minute ago, when we have an ionic compound, we don't show these bonds in there. If I were to draw the structure of that, I'd show these covalent bonds in here. But now I've got this positive ion, propyl ammonium. This is propylamine. Plus hydrochloric acid is going to form propyl ammonium chloride. All right? I told you as we began this chapter that ammonia has 3 bonds around it. Amines. Did I say ammonia? Ammonia and amines. Nitrogen has 3 bonds. So we get that sort of situation. And whenever it is that way, we're talking about ammonia or an amine. But whenever we put a fourth thing on there, and that's what we've done right here. This thing has 4 things around it. It has 3 hydrogens, and it has a propyl group. It has 4 things around it. No longer do we call it an amine, we call it an ammonium something. In that case, it's propyl ammonium chloride. This thing has a positive charge, and there's a chloride ion next to it with a negative charge. It's a salt. If you go home and you have a supplement you're taking or a prescription that you're taking, take a look at the name of it. This won't always be the case, but frequently you will find them saying this is hydrogen chloride. All right, hydrogen chloride. And what are they talking about there? Usually, a lot of times, there is an amine functional group, like L-lysine. Lysine is a essential amino acid. Some people take it as a supplement, feeling like they don't get enough lysine in the food they're eating. Some people do. It is an amine functional amino acid, and they will, you look at the bottle, at the back, it'll say L-lysine hydrochloride. And they're converting the amine into the hydrochloride salt of that amine. And why are they doing that? You think, why are they playing around with that? Well, those of you that were in the 1107 lab this morning, let's not confuse it. This is more soluble in water than this is. The amine all by itself has a certain level of solubility. That particular amine, not really very high. It's got this propyl group on it, so it's not real soluble in water. But if you convert it into a salt by just reacting it with hydrochloric acid, a little bit of hydrochloric acid, it increases the solubility in water. Now, why would they want to take a supplement or a prescription drug and make it more soluble in water? Why? So go in your body faster. Something they will talk about right now is bioavailability. Okay? You take something and they'll say it's 80% bioavailable, which means they're usually talking by ingestion, not by IVs. But you swallow it, and 80% of it will get absorbed in your body, and 20% of it will go right through your digestive system. It's not all going to be absorbed. So you say, you're taking 500 milligrams of this, but you're only getting 400 milligrams of it in your body. Follow me? This will make it more bioavailable because of its solubility in water. This is the way a lot of stuff is being absorbed across the intestinal walls, is by through water. It's in a water medium, and it's going across that intestinal barrier through this aqueous phase. So this will increase bioavailability. So they take a drug that's very hard to make, very expensive. It's not very good if it's only 50% bioavailable. 50% of it is just going right through your digestive system. So you have to actually double the dosage in order to get in your body what you need. So they convert it. So this is an important, I'd just like you to be aware of this whenever you see that. Don't be afraid of this. You think, well, man, is that acidic? No, it's not really acidic. It's been converted into the salt, and it's neutral. But how did they make that salt? They had to react it with a little HCl to make the salt. All right, so I said ammonium. Remember, ammonia plus water forms ammonium hydroxide. We call this ammonium. That's the ammonium ion. All right, so you're going to see this word just like you just saw it here, propyl ammonium chloride. It doesn't mean it's the NH4+, but it does mean it is the nitrogen with 4 things around it. So we changed the name from amine to ammonium, whatever it is, propyl ammonium, ethyl ammonium, methyl ammonium, phenyl ammonium, whatever it is. Ammonium. So whenever you're seeing the +1 charge, and that's what it always is, it just goes to a +1 charge. Yes, there are 4 things around there, but it's only that 4th hydrogen that brought in the positive charge. It was actually an H+ that got added to the nitrogen, and it makes it an N with 4 things around it with a +1 charge. Yeah, that's what makes it ammonium. +1 charge, 4 things around the nitrogen. When you have 4 things substituted on the nitrogen, it's going to have a +1 charge. Okay. In the previous, let's just make a comparison here. Ignore that just for a minute. Let's say we had this situation. I just want to do this so you see the comparison. Let's say we reacted that with HCl. And we're going to get, a hydrogen right here. And is there going to be a plus charge on this thing, and we're going to get a chloride. And so what we would have here is this is trimethyl amine plus HCl. All right, so now help me name this. What do we get? What is the name of this? It's a salt. Yeah, just take the amine. Don't change anything except this right here. Just change this to ammonium and add the chloride to it. Trimethyl ammonium chloride. All right? I mean, this right here is sodium chloride. You name the positive ion, sodium, negative ion, chloride. You got sodium chloride. What's our positive ion? Triethyl ammonium. And our negative ion is chloride. Okay? So just change that. Whenever you see 4 things around the nitrogen, slip this into the name. Change the amine to ammonium. Okay, now I put this right here because I want you to see. Here I got HCl. What do I have here? Methyl Cl, methyl chloride. I don't have HCl, I got methyl chloride. And if I do a comparable thing, if this nitrogen now pulls that methyl group onto the nitrogen and leaves the carbon-chlorine bond behind to make that a chloride ion. See, we got a +1 ion here, -1 ion there. Now I got tetramethyl. This is trimethylamine, but now I got tetramethyl ammonium chloride. You see that? I can't call it trimethylamine anymore because there are 4 of them. Trimethylamine plus methyl chloride forms tetramethylammonium chloride, a quat salt. The word quat is coming from quaternary, or 4. Quaternary. This isn't a quartet, it's a quaternary salt. These are pretty interesting. All right, these are pretty interesting, and you're going to see some neurotransmitters that are actually quat salts in just a minute. So naturally occurring, your body's making them. They're neurotransmitters, very important molecules, and they're quat salts. So it's good to know. Tristan?
So this reaction goes to that reaction, and that one can go further into the tetramethylammonium.
Well, there's just an analogy here. This, you're reacting with HCl, and you're getting an H here. Okay, so don't mix these two up. They're 2 separate reactions. But I'm just showing you here that, do I have the names under there? That I've taken trimethylamine with HCl, and I'm getting an H there, and a chloride. I'm taking trimethylamine with methyl chloride, and I don't get an H, I get a methyl. I get another carbon. I get a 4th carbon on there. This is not a quat salt. Quat means there's 4 carbons around this thing. 4 carbons. This is just trimethylammonium chloride. This is a simple base plus an acid forms that salt. But here is a tetramethylammonium chloride. Here's your quat. 4 carbons around it. They don't have to be methyls, just 4 carbons onto that nitrogen.
So since there's 4 carbons around there, it doesn't change into like any kind of butyl whatever. It still leaves it like.
Yeah, butyl would be 4 carbons in a row. You can see those carbons are not attached to each other. They're attached to the nitrogen, not to each other. It's not a chain. Well, in our previous slide, we had the propyl. Those were 3 carbons in a row attached to a nitrogen. We called it propyl. But these are just 4 methyl groups around there. Nothing butyl about it. Let me tell you a little story from my past experience. When I worked at Dow Corning and we worked with silicones, there was someone there that probably went off to become a millionaire. He had a dog, and he would take the dog to the vet, and he'd sit there waiting for his appointment to come up, and thinking, man, this waiting room, smells like animals. Smells like a lot of animals have been in here. And so he'd come back, he was in research at Dow Corning, and he'd come back and start working on some things, trying to figure out some way to clean up the odor in veterinary offices. And he understood that certain quat salts are antibacterial and antifungal. And so he attached these to silicones and a treatment that you could actually wipe all the walls and all the counters and the floors and the carpet and everything with this stuff, and it would bind these quat salts to the surface, and no bacteria would grow on it. And he kind of cleaned up the odor in his veterinary's office. And what happened is, I don't know if he discovered it or decided it or whatever, he said, well, I wonder who else would use this. Hospitals, operating rooms. And they started treating operating rooms with the stuff that he had developed. It's a Dow Corning A5700 emulsion, antibacterial emulsion. And it just spawned a huge industry. They spun it off. Dow Corning spun it off as a separate little company that started hiring applicators to go out and spray buildings and operating rooms, and then people making socks. They put it on socks, and you get these BioGuard socks that don't stink. You go jogging all the time and they don't smell like a locker room. And they started putting it on carpeting and started putting in all kinds of stuff that's antibacterial. And what the silicone does is it binds it to the surface of the paint and has these little quat salts on the surface so the bacteria can't be on there. You could put it on a countertop, but if you scoured that countertop, it would take it off. So you could have braided it off. But if it was on surfaces that pretty much were untouched, or you cleaned them gently or in a certain way, it was pretty permanent. Even like BioGuard socks. Throw it in the washing machine and it stays on there for a long, long time. And what he's putting on there are quat salts. And I forget what the name of that business was. We actually made, in our plant, we made the emulsion, or we made the product and then shipped it over to them, and they applied it and sold it and distributed it, did all this stuff. But from, an unpleasant veterinary office experience came that product. Okay, chemical properties. So all right, so here's choline. This is, so you see you got 3 methyls here. 1, 2, 3. And you have this group, a 4th carbon on it, so that's a quat salt. They don't all have to be methyls. 3 of them are. And then you convert that to the acetyl. It's not doing anything down here, but acetylcholine. And these are neurotransmitters that your body produces. Choline and acetylcholine. So there are, biologically active quaternary salts. All right, and there's a +1 charge on here. This is a positively charged species there, right there. There would be a counterbalancing chloride somewhere, or a counterbalancing negative ion of some sort. It could be, probably most often is chloride. So I mentioned this already. Amine salts are more soluble in water than the parent amines. Hence, amine drugs are converted to amine salts for easy absorption in the body. All right, I'll just mention some things to be aware of. If we talk about a heterocyclic amine, the pyrimidine ring, the purine ring, heterocyclic, carbons and nitrogen. Carbon and nitrogen in the same ring. So 2 different atoms, 2 different elements in the same ring, and this is aromatic. Pyrimidine, purine. These will come up in chapter 20 when we start talking about nucleic acids. So adenosine, guanine, cytosine, thymine are based off of these 2 rings. So this smaller ring, single ring, has got the long name, and this fused double ring has the short name, if that helps you remember them. All right, let's segue over into amides. Amides. So I'll just make this a little bit bigger here. That's fundamentally your amide functional group. You have a carbonyl and an amine, or a nitrogen, right next to it. This is the amide. In the amines, we haven't seen this. Just amine is just, without that, you have an amine. But when you have a carbon-oxygen double bond on the nitrogen, it's an amide. and naming of them. This gets a little confusing to some people. Sometimes they look at that and they see a methyl sitting there and they'll call it methanamide, but you shouldn't do that. Look at how many carbons, 2 carbons. It's an amide. The longest chain is 2 carbons, so it's going to be ethanamide. So what are you doing? They're more or less saying, if that was an OH instead of an NH2, you'd have ethanoic acid. Well, convert it to ethanamide. Or another way, if this is easier for you, drop the E and add amide. Ethane, it's 2 carbons long, so it'd be ethane, but it has got that amide functional group right there, so it's ethanamide. Propanamide. This also has a name, and we'll have a slide here in just a second to show you which molecules you should memorize. But this is also called acetic acid, and it's going to be acetamide. Acetamide. 2 carbons. So acetaldehyde, acetic acid, and now you got acetamide. You can even carry the N nomenclature in here. You can see this would be propanamide right here, but the nitrogen doesn't have another hydrogen on it, it has a methyl, so it's N-methyl propanamide. See the comparison? There's your propanamide, this is your N-methyl propanamide. This hexanamide, 1, 2, 3, 4, 5, 6 carbons long, hexanamide. That amide always has to be on the end. It can't be in the middle. Here's another confusing thing. Can be confusing. Sometimes people come along here and they just count right through here. 6, 7, 8, 9, 10. They just throw the nitrogen in there, or they'll skip the nitrogen, 6, 7, 8, 9. It's the longest continuous chain of carbons. This is another chain, short chain, that's propyl. This is hexane, or hexanamide. Okay, so you need a 3x5 card for that. And that.
So you don't want a 3x card for the ones you have access by?
I do. These are the ones you need 3x5 cards for. Is that better?
Yeah. They look like you were like, oh, you don't need those.
Those are the ones you need. Maybe I should have put a check mark. Check mark. X was kind of Xing it out. And then someone punch in benzamide. You got a browser up. Punch in benzamide.
benzamide.
Yes.
Formula?
Yeah, is that benzamide? Okay, so there's benzamide. You probably should add that one too. Does it have an alternate name for that?
Phenol carboxamide?
Yeah, that's a crummy name. Benzamide. Let's go with benzamide. Okay, so there's your benzene ring with an amide functionality attached to it. So the benzamide is attached to it. You should have a 3x5 card for that one.
Derivative of benzoic acid.
Yeah, so you're converting benzoic acid into an amide. So instead of an OH, you're adding an NH2. So there's benzoic acid. Yeah, I mean, if you looked at benzamide and say, what is the comparable carboxylic acid to it, this is it. Take the NH2 off of there and add an OH. Okay, now just remember the meth, one carbon, remember formaldehyde? Methanol was also called formaldehyde. Methanoic acid was called formic acid. And now we have methanamide. You don't see any methyl group over there, but you just see one carbon. So that's methanamide. This is ethanamide. Don't get those two mixed up. And they have these common names, formamide and acid amide. Physical properties, I've emphasized this a whole lot more with alkanes, alcohols, aldehydes, carboxylic acids. Yes, there is some polarity to an amide because you have a carbon-oxygen double bond, but I'm not going to dwell on that. These aren't real polar. There is some polarity. So they're more soluble in water than alkanes, but not as soluble in water as alcohols. So yeah, that comparison is there. And I'm not going to emphasize reactions of them. You can react an amide with a strong acid and form a carboxylic acid and an amine. You can react an amide with a strong base and form an amine, but also the salt of the carboxylic acid. But don't just to name, be able to name, know the amide functional group, know what it looks like, be able to name some simple common amides: methanamide, formamide, ethanamide, acid amide, benzamide. All right, now here's some biologically important ones, and you don't have to memorize these structures. The purpose of these slides is to just show you this class of compound we're looking at right now is very medically significant. So when you talk about dopamine, I mean, it's got amine in the name. Dopamine. Epinephrine. So you're taking dopamine and modifying it a little bit. You've got an OH here, and you've got a secondary amine right there. I might give you some of these molecules and say which of the following is a primary amine. Things like that. So I might even use some of these examples. Serotonin. Serotonin. So now you've got the ammonium form, serotonin. Histamine. So antihistamines are trying to stop the release of histamine. Antihistamines are trying to shut down the receptors that would trigger the release of histamine, which causes the allergic reaction. And so those are antihistamines. But there's histamine, acetylcholine we already looked at, a quaternary salt. Morphine, codeine, you can see the nitrogens popping up in caffeine, nicotine, popping up in a lot of biologically active molecules. Benzodrine, methadrine, so amphetamines. Novocaine, so there's your tertiary amine right there, Novocaine and an amine here. Demerol. Medically important amines. Kind of a complicated one with sulfur in it. You can see some of the ring structures and associations of things get kind of a little more complicated. Valium, heterocyclic amine here. Aspartam and neotam. Aspartam, synthetic sweetener, so it's an amide bond between aspartic acid and phenylalanine, but this is not just phenylalanine. It's got a methyl group on it, so it's been tweaked a little bit synthetically. And so the PKU, people that are PKU, phenylketonuria, can actually go into a toxic reaction to phenylalanine. There's a warning sign on aspartam, that this would have an adverse reaction possibly to someone who is PKU. Because it can break, that bond can break and release phenylalanine. So that bond breaks and it can also release that methyl group as methanol. So that's some of the background. Reaction schematic. Let's go to... Okay, so this is chapter 13, or no, chapter 15. Chapter 15, and at the end of these slides, I have the ending slide for chapter 15, 14, and 13, kind of as a place where you can go and look at all the reactions that you should be able to carry out. Just be aware of this. There's a way to make amines from nitro compounds and amides. You should, I'll use a check mark. You should be able to write out a reaction of an amine with water to form the ammonium ion and the hydroxide ion, showing that it is a weak base. It's dissociating, it's causing water to dissociate to form the hydroxide ion, so it's a weak base. So because it is a base, it can react with an acid. And just don't worry about any other acid than HCl, hydrochloric acid. So how does an amine react with hydrochloric acid? It forms the ammonium chloride, whatever it was. If this was a methylamine becomes methyl ammonium chloride. Ammonium chloride. And you don't need to worry about those. Chapter 13. Chapter 13 is there, and then you have a primary alcohol oxidizes to an aldehyde. A secondary alcohol oxidizes to a ketone. Under the category of how do you prepare aldehydes and ketone. That's chapter 13. This is a little bit more for Monday. Next Monday, when you have your exam. This is kind of a summary of the reactions you should be familiar with.
Can you come back up?
All right? Okay, now, get out of there. Yeah, why is that there? What is this? This is chapter 13 also? Yeah, okay. This is the same thing. Oxidation of an aldehyde to a carboxylic acid. You can form a hemiketal. You can form a hemiacetal. You don't need to worry about these two reactions. The reduction, yes. Reduction of aldehydes and ketones to form either the primary or secondary alcohol. We've gone over this when we ended chapter 13. Can I go on? And then chapter 14, is this chapter? Yeah, this is chapter 14. So yeah, for the quiz Wednesday, all these chapter 13 and 14 reactions that I'm talking about. So a primary alcohol goes to an aldehyde, goes to a carboxylic acid. Dissociation of a carboxylic acid, neutralization, esterification, hydrolysis, saponification. And then I said I wouldn't hold you responsible for the acid chlorides or the acid anhydrides. And you should be familiar with what we're talking about when we talk about a phosphate ester. All right, now if I have a volunteer to hand this practice quiz out, I'll go over to Canvas and very good. Give everybody one of those. I'll pull up Canvas. If what I'm going to hunt for on Canvas is that table of, and I didn't log this in to. Maybe I could pull that up too. We can do one of them. All right, let's see what I can do here. What do I mean by a practice quiz? That's a good question. Thank you. This is not cooperating real well. I'm trying to find in Canvas is that table, chapter, actually it could be chapters 10 through 15 table of the compounds that you need to have 3x5 cards on. Okay, does somebody have that table? Anybody find that table? I don't think my keyboard isn't letting me type right now. I don't know why.
Is it this one?
This one right here?
Probably. Yeah, it is that one. No, it's not that one. It's it is this one, but it's the, see, that's key terms. These are the compounds. That one.
Okay.
It's the same spreadsheet. I think I might be able to call it up right here.
Oh my God. No, she said that.
Let's try to do that.
It's under your files.
Yeah, so I have something here called study guides. Let me show you how I would recommend you use this practice quiz.
Study guide for chapters 10 to 15. I think it might not be in a file. Go all the way down.
Maybe. I think so.
I have mine printed out.
Okay, here, see right.
There we go. Table 10 to 15.
Yeah, tables 10 through 15. This is on Canvas. I just can't get to it right now, but it's on my thumb drive also. So let's just take a look at this. It's the chapter 10 through 15 table, and Whitney called it up, but the very first thing she saw was this, which is a list of key terms. Key terms. There are 2 spreadsheets in here. This is the most important one. I wish this one came up first. But it's all in the same book, Excel book, but this is the one that's important. So, so let's look at chapters 13. Probably we could start with chapter 12, 13, and 14, but let's look at chapter 13. So what is this? These are the molecules that you should know: the IUPAC name, the common name, and the structure. All right? So you should have a 3x5 card with these names on one side and the structure on the other side. So let's take a look at this. I didn't number these, but let's look at, let's go down to the third one. You see where it says right, the instructions are right at the complete reaction, reactants and products using structural formulas. Third one down, for the hydrogenation or reduction of blank. So you say, what am I supposed to do with this? Okay, probably your quiz on Wednesday is going to be any one of these 7 reactions. Probably be 5 of these 7 reactions. So these are the reactions. You need to learn how to complete these reactions. With what? Well, for the hydrogenation or reduction of. What am I telling you there? Those two are the same thing. So whether I use the word hydrogenation or reduction of what? Well, this is saying put in any aldehyde or ketone. All right? So now come on over here, chapter 13, aldehydes and ketones. I'm going to only pick from these right here. So pick one. Benzaldehyde. Okay, let's see. So benzaldehyde. That probably is the hardest one there.
That's why I picked it.
So benzaldehyde. So start with benzaldehyde. That's benzaldehyde. Plus, what is it going to react with? H2. Hydrogenation. Right in the name. And what is going on here? Hydrogen is going to add, there's 2 hydrogens here. One is going to add to the carbon, one is going to add to the oxygen.
Instead of the double bonded O, it's going to be an OH.
Yes. And that is not, don't worry about naming that particular one. If the OH was right there, it'd be phenol, but that's not phenol. It's got a CH2OH right there. So,
What would that name be?
yeah, don't worry about it. I'm not sure right offhand. I don't know, benzeno alcohol or something like that. Benzoyl alcohol, something like that. But so you could just pick off any one of these aldehydes or ketones, butanal, formaldehyde. Like I said, that's the hardest one over there. Formaldehyde, you're going to get a hydrogen here and a hydrogen here. And you get a hydrogen there and another hydrogen there. So formaldehyde reduces back down to what? What is that?
Methanol?
Methanol. Yeah, I probably won't have you name the products, but I have you complete the reactions. All right, so you can go right in here. So for the oxidation of an alcohol, go above here to chapter 12 and pick out an alcohol and oxidize it.
And those are the only ones you're going to pick from?
Yeah, I think I'll just pick from these that are on this table of the ones that I said memorize these compounds. Pretty much so. If I didn't, it would be an IUPAC name of a molecule. You would be able to draw it from its name. Like 3-methylbutanol, 2-butanol or something like that. You'd be able to draw that molecule and then do the hydrogenation of it.
And this quiz,
But I probably will pick off of these right here. 12, 13, and 14, not 15. All right? There'll probably be 5 reactions worth 4 points each for 20 points. I've never been this prescriptive about a quiz, okay? I mean, I've left a lot of blanks, but you practice these, it'll drill these kind of reactions into you. The purpose of this quiz isn't to catch you doing something wrong, it's to, and the purpose of this whole thing is to encourage you to get familiar with these reactions. All right? Okay. 1 minute and then you can be dismissed. The Cytober is tomorrow morning, 10 to 3, something like that. Look at the flyers. And Wednesday, so tomorrow is Mold Day. It's October 23rd tomorrow. Tomorrow's Mold Day. Get those passports. I only Friday heard that they're going to be encouraging you to turn your passport in so that you can be part of a drawing, and they're going to be giving away some prizes. So take a picture, do something. Student Success is going to get this information back to the instructors. So if you turn in your passport, make sure your name is printed on there very correctly. I don't know if they're going to want your banner ID as well. Because Student Success, at least what I heard, is going to log all of these into a spreadsheet, figure out whose classes you guys are in, and send me a list. Say, these people turned in a passport.
So you said tomorrow and Wednesday, right?
Tomorrow and Wednesday.
So because on Wednesday we turn it in on Monday.
Turn it in, probably you could turn it in there. If you don't want to be part of the drawing, just bring it to me.
What time does it start?
I don't know, it's 9 or 10 o'clock in the morning, something like that.
Can we take pictures of it and email it to you?
I think so, yeah. We could do that. All right. Enjoy Moldy.